Welcome to Impact Unicorns, the podcast where you meet inspirational entrepreneurs building the next generation of transformative companies. And now, here is your host, Dr. Indranil Ghosh, award-winning author, investor, and advisor to global leaders.
Welcome to another show of Impact Unicorns. I'm Indranil Ghosh, your host. And today I've got a very exciting guest, Mr. Jason Huang, who is the CEO and founder of TS Conductor, a high-efficiency electrical cable company that just achieved a very impressive Series A funding round. Jason has a PhD in material science, comes from a very scientific, technical background, but has also been CEO and CTO of CDC Global, an industrial company, as well as vice president of BAE Systems. Jason, it's really great to have you on the show. How are you doing?
Thank you very much, Indranil. Thanks for that very kind introduction. It's a pleasure to chat with you in this forum.
It's great to have you. Look, sometimes people don't think about simple things like the electrical grid and the fact that we have thousands of kilometers of electrical cables connecting power generation facilities like power plants to big urban cities, that keep our lights on. And we just don't even think about it. But if you do think about it, then you'd realize that there are actually large losses that occur, energy losses in transporting energy from where it's produced to where it's needed. And if we could reduce those energy losses, even by a small amount, if you were to apply those efficiency gains across the global grid, we would be talking about hundreds of millions of dollars of savings per year, if not more. And so that is really, as I understand it, the premise of TS Conductor, to gain not little, but actually huge efficiency gains in the way we transmit electricity. And I can't think of, a business model, or I can't think of too many business models which can have that kind of, financial impact on the energy system, as well as the obvious environmental impact of all of the energy that's saved. And therefore reduces the need to produce certainly hydrocarbon-based energy, but even makes better use of the renewable energy. So I'm very excited to talk about all of this, but maybe you could tell us a little bit about how you came to start a business like TS Conductor. What was the genesis of this idea, and how did all the experiences in your life lead up to that business creation moment?
Yeah, I'd be very happy to answer that question. As you said, I do have a technical background in material science, and I spent about 20 plus years in the aerospace side, specifically carbon fiber composites that are used in the aerospace. I worked in majority of the commercial airplane platforms, the 787s, the A350s, for example, as well as the military side of advanced aircraft. All of them have carbon fiber composite in it, because that is the way the material science works, and that's the way these applications demand that type of performance. Back in 2010, I had the opportunity to consider an option to move in a very different direction. That is applying composite material for power grid, for conductors. And I was convinced at the time that that is the area where composite material can make a huge difference, actually an enabling difference. That's why, and that's how I changed my career from aerospace to utility to conductors. Because of that involvement, I had the intimate knowledge of how and why material works in certain applications, but also be humble enough to understand what are the limitations. And there are limitations in the what I would call first generation conductor solutions that leverage carbon fiber composite. So in 2017, I had the opportunity to to basically take on interesting challenge that is aligned with what I have been doing, but in a far more transformational, exciting technology platform. Basically, it combined the best features in the aluminum side and the best features of a strength member. And that's what TS is today.
Yes, I think for a lot of people who might not be familiar with something as simple as electrical conductors, maybe you can talk a little bit about the material science part of it, because electrical cable, how is it, what is it made of today? And what are the important properties that, make a good cable today? And how do you improve upon that? What are the things that you can improve and what are the things you can't compromise?
Yeah, that's a very loaded question. It's a simple but loaded question. I have to go back about 100 years, how the conductors are invented, or the current form of conductor are applied to the utility industry. Back in 1908, we have this conductor called ACSR, which is basically aluminum, hard aluminum, combined with high strength steel. And that is the best material science can offer at that time. And what you need, or what you look for in a conductor, is high electrical conductivity or high electrical performance combined with a necessary mechanical attribute. What is the mechanical attribute you are looking for? Imagine all these conductors are sitting between the towers. So you can imagine they're in air, mid-air. So you like it to be lightweight. You also like it to be low sagging, because we need to maintain a minimum clearance from the ground, from a building. That means the material shouldn't have a lot of summer expansions to it, because during summertime, when you have a lot of current, it's going to expand. It's going to increase length. That's why you have sag. And you also want the material to have enough strength, because you're carrying all those weight on its own. On the aluminum side, you wanted to aim for the maximum electrical performance you can, while having the ability to go to high temperature for example, emergency situations. So looking back, 1908, they had to use something called hard aluminum, which doesn't have the best electrical, but it does have very good strength. Why they need the strength? Because the steel is not strong enough. And on the steel side, you can imagine hand steel between towers. It's like sitting in the air, right? It's heavy. It is also got a very high thermal expansion. It's not really that strong. So this is why you wanted to have materials that are lightweight, that has no thermal expansion, that is super strong, and the aluminum is the most conductive aluminum, that is the annealed aluminum. So if you can combine the two together, you have the best combination in conductor, and that is what TS has in its product design.
If you're enjoying Impact Unicorns, don't forget to like, subscribe, and hit the bell to receive notifications of new shows. Bring the most relevant impact venture stories to the podcast. If you would like to review the show, go to the Apple Podcasts mobile app or iTunes to leave a rating and review.
And has there been much innovation in the last 100 years on that formula? And if not, why do you think that is? Is it because the technology wasn't there, or are there other sort of commercial reasons why there's been no real need to change something that worked reasonably well?
I would say there are two aspects to it. One is the availability of material innovations, and you can't have a new application if the basic material is not available. Advanced carbon composite was used in the aerospace side about 50 years ago. And by about early 2000s, you got more of the major, even commercial aircraft using carbon fiber composite platform. So that's been around for the past 50 years. And when we talk about the aluminum, the most conductive aluminum was also used in the conductor form called ACSS. That is basically combining the higher strength steel with these most conductive aluminum. And that was also introduced about 50 years ago. So you do have some innovations along the way, but the other impediment in the industry, it is also quite a factor. The industry typically is very conservative, very slow in adopting new technology. And that's why we're in the 2022 And we're probably 90%, 95% of the conductors in our power grid is still reliant on still the same as the 1908 technology. Nothing really changed.
That's very interesting. And, it must therefore be a challenge to not only come up with a technological solution that works, but one for which whatever materials you need are widely available or easily available and manufactured to keep the cost competitive to manufacture. It's obviously got to have some sort of performance, significant performance improvement, but it's got to be worth the electricity company's while to make the change. So what is it, the special combination of factors that you bring together in TS Conductor to crack the code on all of those three buckets?
I would be very happy to address that. It's a very smart question. When you look at using composite to substitute for steel, that is the right direction. You reduce weight, you reduce thermal expansion, and you are using more conductive aluminum. However, in the past attempts using composite to replace steel, there are limitations related to the composite itself is brittle. The composite is not conducive with traditional work method. There are trainings required, and there are also vulnerability associated with composites if you don't protect it well. And these are aspects that you have to address in addition to the cost that you mentioned about. And cost also had to do with application. If your product is positioned as a niche because of certain limitations, because of the three limitations we just talked about, your market is going to be small. You will not be able to reduce the price to a level that is compatible with mainstream adoption, right? So on the three major challenges we talked about, the material being brittle, the material cannot be made to work with conventional or standard work method, and the material need to be protected. In the TS configuration, we actually cleverly leveraged the conductive aluminum. We took part of those aluminum, used it not only for electrical conductivity, but also to effectively protect that carbon composite core. And how do we do that? We basically have the composite shrouded or encapsulated in a relatively thick aluminum layer. That gave you the cushion to allow you to work with all the traditional training, tools, equipment, methodologies in the industry. That layer of aluminum encapsulation also protects the composite from environmental degradations. You don't have moisture, you don't have air, you don't have UVs, all these vulnerable degradation agents. And most importantly, it also provided the necessary robustness for the composite type of conductor to be broadly used. Your audience can check out our website to kind of see the comparison before and after applying the TS design technology. And I can take a whole day to explain that. We don't have time for it. I encourage, if some of you are interested, you can check out our website. It's www.tsconductor.com.
It seems like you got the right combination of electrical properties, because as I understand it, there's significant efficiencies, much less losses when you're transmitting electricity through TS cables. You got the right thermomechanical properties, so it wasn't brittle, doesn't sag too much, still strong, and it seems to be reasonably at parity in terms of cost of manufacturing with traditional cables. Is that, maybe you could just sort of confirm that the sort of assessment there, and tell us a little bit more specifically, what are the energy savings and what is the relative cost of manufacturing?
Yeah. I could confirm that TS Conductor does offer the highest ampacity possible, the best efficiency that you can achieve on the same size conductor compared to any other types, number one. Number two, the efficiency that we can deliver, it can be as much as 50% or less, 50%, as much as 50% of the previous generation conductors. What does that mean? I think in the openings, you mentioned about very high line loss or electricity loss in the power grid, transmission and distribution. There was a number that was published by DOE a couple of years back. On average, the global line loss is about 8.3%. If you multiply that by the amount of electricity generation worldwide, we are talking about 2,000 terawatt of electricity lost every year. That is in the billions if you talk about economic value. But more importantly, you have to make up for that loss. So you basically have to do what is called compensatory generation to make up for that. The compensatory generation alone is estimated to be responsible for 1 billion metric ton of greenhouse gas each year. If you can reduce that by half, that's a monumental impact to climate change. And on top of that, the efficiency is only one aspect of what TS brings. TS, it also enables the power lines using the same right-of-way and same structures to double the line capacity. What does that mean? A lot of the renewables today, actually majority of them, are not able to be integrated or interconnected to the power grid because there's bottleneck in capacity. And our grid is not configured to accommodate these renewable generation. They're normally in a place that nobody lives, and you don't have that infrastructure. We needed to address that. There's also the need to address the resiliency issue, especially because of the climate change or the extreme weathers. And TS Conductor can also make a major difference in that category as well.
And what about the cost of manufacturing? So, if you were to, compare it with the equivalent cable that would carry the same amount of electricity, so that it's a fair comparison, what is the cost of manufacturing TS cable versus the current standard?
Yeah, the cost is one aspect. The price that you bring to the market is going to be somewhat different. Let me just address the cost. The manufacturing process that we use for making the composite is probably the most mature, lowest cost manufacturing platform for composite manufacturing. It's called protrusion. It's a highly automated process. It's a very simple, straightforward way of making a composite. You basically have these carbon fibers go through a resin bath, and after the fibers are impregnated with resin, it goes through a curing die, which is probably about 1 meter long. And at the other end, you have basically the cured composite. You don't need many laborers, and the equipment can be scaled up very quickly. So the cost of the manufacturing of the product is very, very competitive. You are not going to be able to find a better way of making composite. That's number one. And number two, when you look at the cost, there's a scaling factor as well. We do anticipate that we can benefit from large volumes deployment and large scale of manufacturing. So where we are today, TS Conductor is priced about 2x or a little bit over 2x compared to the conventional. We do anticipate we can do that below 2 in the coming years to enable mainstream adoption of this technology. And you might look at the first cost in the conductor being high. However, when you look at what I would call upfront CapEx, that includes the towers that you may have to spend money on and the right of way that you have to acquire if you build new ones. But if you are doing reconductoring, for example, you don't even need to spend money on the right of way or on the towers. And our solution uniquely allow you to do doubling of the capacity without any structural retrofit. That's where you can save huge amount of money. So overall, we do offer a very competitive CapEx option. Actually, most of the time it will be better. And if you look at it from a life cycle benefit perspective, it is a no-brainer in terms of line loss savings every year for the next 30 to 50 years. You can run that math, and the conclusion will be very obvious.
Sounds like an absolute no-brainer. What kind of market traction are you getting with customers? And are there different segments that are adopting faster or slower than others? And why do you think that is?
Yeah, we are a relatively new product or technology, and our product, however, have been very successfully deployed in both transmission circuit as well as in distribution circuit. It includes 10 kV, 35 kVs in the distribution side, and it has already been deployed in 110 kV, 220 kV, 230 kV, 330 kV, and 345 kV. There is no limitation in terms of the voltage. In terms of volume manufacturing, we have already done that, scaled up in terms of our manufacturing. In terms of the volumes, we do anticipate a major uptake in the coming years. Right now, we're focused on some of the major IOUs that we've been working with in the US. We have a pilot line, for example, with Exelon, and they're helping us on the EPRI testing front, as well as some of the testings that we're doing on our own. We have done extensive testings in places like in India, China, basically the developing countries, but we have not been able to gather together the resources to finish the type testing in North American market. And we are doing that. We expect that to be in place. Basically, it's a simple duplication of what we have done in other countries. With that in place, and with our manufacturing facility that's going to be in production ready state around summertime, we will be able to make a much greater penetration in the all important US market. This is our home market. And we also do have anticipations, expectations as well to work with our partners who've invested in us, including National Grid. I was in National Grid a couple of months ago. I have been very impressed with the visionary leadership at National Grid, JP, the board chairman, the chief engineer, David, and chief technology officer, Lisa. A world-class organization that is leading the charge related to climate change. We're very excited about that.
Over the past 20 years, I've worked with hundreds of entrepreneurs to build impact unicorns. In my experience, every company that has a transformative positive effect on the world does so by building strong partnerships with communities, investors, and governments to solve society's biggest challenges. If you'd like to learn more about how innovative entrepreneurs can help to build a more sustainable and inclusive future, read my award-winning book, Powering Prosperity, A Citizen's Guide to Shaping the 21st Century.
So, Jason, the whole kind of repowering opportunity seems really interesting to me. So, this is when you want to replace old cables. And you have the choice of replacing them with the same old cable or something new. Now, if what you're saying is with TS conductor cables, you don't need to change any of the towers, change anything really. You take down the old cables, put this new TS cable on, and it's going to cost a bit more in terms of price, but you're going to quickly make that back up in terms of the savings from the lesser energy loss. Surely that's got to be a no-brainer. And is that where you're seeing, new uptake? Because when it comes to building completely new lines, there's all sorts of issues around, getting the permits and the right of way to build a line, and it can take, years and years. But this sort of repowering segment must be really interesting.
Yeah, the reconductoring option is, I would say, the fastest and also the most economical way to expand our power grid bandwidth. The capacity in our transmission or distribution power grid is the bottleneck in terms of getting to this electrifying everything, getting to the net zero economy or zero carbon electricity. In the power grid, what is the most critical limiting factor? It is the conductors where the electron passes through, which is, you can imagine that in the pipeline for electrons. You need that pipeline to be efficient. You also need that pipeline to be high capacity. As you said, acquiring the new right-of-way is virtually impossible. All the permittings and all the negotiations, it could take years. If you already have the right-of-way and you already have the structures in place, the options you have is, I will either put a larger conventional conductor in so that I have more capacity. You will have to redo your towers because All the existing lines are already optimized for the old size conductor in terms of clearance, in terms of the handling the weather load. So that's not going to work. If you use alternatives, mentioned about the 50-year-old technology called ACSS, it has a near aluminum. It does go to high temperature, but it's pretty saggy. What does that mean when you have a saggy conductor? Well, if you wanted to push to that high current situation, which is you have to run it hot, the line sags. If the line sags, your tower has to be raised taller. That's going to require more money, and it's also going to require more outage time to do those retrofit. If you use TS conductor, however, you can just swap the old conductor out for the same size TS conductor, and you are getting 2x capacity, and you don't have to do any of those tower retrofit, which save you money, and you don't have to create a lot of these inconvenience. And at the same time, you are also getting that improved efficiency as a side benefit. If the utility is able to monetize on that line loss saving, that line loss saving in a couple of years can pay for the entire project cost.
That's got to be very compelling for a lot of utilities. So I imagine there would be good uptake. What has it been like to raise money for a project like this, a company like this? I mean, you'd think this has got to be a no-brainer for the investors as well, but reality is far from that smooth usually. So tell us a little bit about what your fundraising journey has been like.
Well, we've had challenges to raise money in the US. So we were lucky to have the first facility established in China with some Chinese investment. And they're a lot more aggressive, or progressive, I should say, in terms of new technology adoption. But the COVID situation in 2020 changed the course for TS. I made a trip back home in the US, and I have been pretty much here for the past 2+ years. That also really focused me for the US market. And we were also very lucky in terms of customer tractions. We had customers like MDU. It's a 230 kV reconductoring. We saved 40% in CapEx. We shaved about a whole year out of a project schedule, comparing the TS option versus the alternative solutions that they have been using in prior project. And we also had utilities like Basin Electric, who is building new transmission lines, 230 kV, and they also find TS to be more attractive from a CapEx standpoint, because we were able to save about 10 feet on average, the tower height. That's enough money to more than cover for the conductor premium. And there are, line loss savings and all those benefits. So in terms of raising money, having customers are important. And also, I would say that having a strong team with a strong leader are also important. And we've been lucky in that regard. And I've had the fortune to have a team that is well established in the industry and has a very diverse background. Our CTO is from India. Our Chief Strategy Officer is from France. Our CFO is from Spain. And our VP of Operation is from Italy. And our marketing sales person is from US. And I originally came out of China. I do feel very optimistic in terms of this market space, in terms of market potential, in terms of societal needs. And when you can marry your passion with a major problem that society needs, humanity needs, if you cannot get excited about it, I don't know what else could. And we've been very blessed to have investors like Breakthrough Energy Ventures. Their mission is very much aligned with what TS is about. And we have also been blessed with utility sponsors, including National Grid and NextEra. And that's going to make a difference in our journey to the future. Our aim is not a niche solution. We aim to bring this technology to become mainstream for the industry. And we wanted to solve this bandwidth limitation problem. Imagine, Indranil, we're doing the meeting in Zoom. We got crisp pictures, crisp sound. All of it is free. This is all enabled by the virtually unlimited bandwidth in telecom, in datacom. Imagine if you have a world where the power grid has unlimited bandwidth to move electrons from generation to wherever it is needed. Imagine the possibilities. Imagine that pipeline is also as efficient as you could ever make it to be. That is the future in 20 years. And TS intend to play a major role in it.
I think that's an incredible vision, and what a note to end on there. If you can't get excited about a worthy project that is going to change the world, then what can you get excited about? I can't think of anything. But you seem to have great backing from superb investors, great customers. You've got a great product. We'll be delighted to see how you're getting on. Hopefully we could check in a year or two and see how the progress has been. I for one, am super excited to see, what the market adoption is going to be like, because the environmental and financial impact of this could be unbelievable. So Jason, with that, thank you so much for spending the time with me today on the show. Really great to hear about TS Conductor's success, and we wish you best going forward.
Thank you very much, Indranil. We need people like you to make a difference in the world. And we're excited about TS technology, and we're also excited about the challenge that's in front of us, because we together can make a difference for the world. So appreciate the opportunity to be on your platform, and be happy to report back how we're doing in a year or two.
Terrific. Thanks again, Jason. All the best.
If you've enjoyed this episode of Impact Unicorns, don't forget to rate and review this show by scrolling down and clicking Rate This Podcast. And join me next week as I talk to more inspirational entrepreneurs building the next generation of transformative companies.